Okay, in this video we are looking at solving equations using trial and improvement. So far we have looked at how to solve linear equations and quadratic equations. With both of those types of equations we either use the balance method when solving linear equations, or when we looked at quadratic equations we factorized them into two sets of brackets and then solved them with the either or strategy at the end. So with linear equations we had one solution typically, and with quadratic equations we had two solutions. Now some equations cannot be solved using either of these methods, and when this happens we can use a trial and improvement strategy. There are two other methods that can be used to solve quadratic equations other than trial and improvement, but those will be dealt with in another video. Okay, today this is just focusing solely on using trial and improvement to solve equations where our normal balance methods or factorizing methods don't work. Okay, if you look at the example below, if I scroll up a bit here, then this is a GCSE question from one of the past papers on the WJEC, and it starts off by saying a solution to the equation x cubed minus 13x equals 107 lies between 5 and 6. Use the method of trial and improvement to find the solution correct to one decimal place. You must show all your working, and it's typically 4 marks for this question. You can see by looking at the question that it's not linear because we've got a cubed term, and it's not quadratic either because quadratic equations go up to x squared and don't have any other higher power than a squared term. They could have a squared term, an x term and a constant term, but they don't have any term that has a higher power than 2, and this has a 3, and this is actually a cubic equation. So typically when we're solving equations using trial and improvement in terms of our exam, they are not linear or quadratic because you have other methods of solving those. Okay, so what does this mean when it says a solution lies between 5 and 6? Well, I'm going to show you why that is the case in a second, and then how to proceed after that. These first two steps though you don't really have to do in the exam. You could start on a value between 5 and 6, but I'm going to show you first why they have told us the solution lies between 5 and 6. Now, as you can see, I've set up a table, got 3 columns. This first column here, the biggest column in the middle, and then a smaller column on the right hand side as well. And what this is for is to help us organize our trial and improvement strategy. So this column is going to be where we put our x values that we're going to try in our equation, because remember, to solve an equation is to find the value of x that works in this equation. So which value of x cubed, take away 13 times that same value, will give me 107. So this column is where I'm going to put all the values of x I'm going to try. In the middle column is the equation that we are trying to solve. Okay, so I'm going to put that there because this is where we substitute our values of x into the equation to see how close we are to 107, and depending on how close we are going to make a judgment, and this column is too small or too big. Okay, and that will become clear in a minute when we start substituting. So why have they told us that the solution lies between 5 and 6? So like I said a couple of minutes ago, you would not normally have to do this. Okay, you don't have to substitute in 5 and 6 because they're telling you the answer is between 5 and 6, but I'm going to show you why. So if we put x equal to 5 into our equation, now remember, when we substitute, I have taught you to put a pair of brackets and replace the letter with its value. So instead of x we put 5 because that's the value of x I'm trying. Minus 13 brackets 5 equals, now we put this on our calculator, and I'm going to bring up a calculator now. So you should be able to see this, and we can type in exactly what we've got on our calculator that you've written down on paper. So brackets 5 bracket x cubed, there we go, subtract 13 bracket 5 bracket. So I've typed in on the calculator exactly what I've got there. Now I'm going to press equals and see that we get 60. Okay, so going back to the whiteboard, I've put in the answer 60. Now we compare that answer with the value that we have in our equation. We're trying to get 107. Well, obviously 60 is a lot smaller than 107, so we say this value of x gave me an answer that was too small. So if we have an answer that's too small, after substituting into the equation, then our value of x must be too small. So you try a bigger value. And the next whole number up from 5 is 6. So if we try 6, and instead of 6, we substitute that in, and going back to my calculator again now. So what you can do here, if you go back and delete the value of 5 inside the brackets, like so, and replace it with 6, it's a lot quicker than typing it all out again. Okay, so we press equals, and this time we get 138. Okay, so 138. I'm going to write that on here, and obviously that's bigger than 107, so that was too big. So this is why they told us that the solution to the equation lies between 5 and 6, because the value of 5 gave us an answer that was too small, and the value of 6 gave us an answer that was too big. So the value of x that is going to work in this equation and give us an answer close to 107 must be between 5 and 6, because the value of 5 gave me an answer of 60 and the value of 6 gave me an answer of 138. Smaller than 107, bigger than 107. Okay, so we understand that. So what we need to do now is to start trying numbers between 5 and 6. Now normally in the exam this is where you would start, because they've told you this, that lies between 5 and 6, you start halfway between them. And halfway between 5 and 6 is of course 5.5. And we are going to substitute that value in now. Okay. So instead of 6, and I'm going to bring the calculator back up. Okay, so we're going to go back now and delete 6 and put 5.5. And go again, delete 5.5, press equals, and when you get a fraction, like remember, press the FD button or SD on a Casio, and you get 94.875. So going back to the whiteboard, 94.875. 94.875. Now comparing that with 107, it's too small, because 94.75 is smaller than 107. So our value of x must be too small, because it's giving me an answer that's too small. So we try a bigger one, and looking at the size of that, I think, oh, I might jump to 5.7 and try that. So write it all down, show all your workings as it says above. So you're showing the examiner and anybody else reading this, you know exactly what you're doing. And this reminds you of what to type in on the calculator. So bringing the calculator back up. If we go back again, this time we've only got to change that one there to 7. So it says 5.7 instead of 5.5. Here we have it. So what do we get? 111.093. 111.093. 111.093. Comparing that to 107, that's too big. Okay, so 5.5 gave us an answer that was too small. 5.7 gave us an answer that was too big. So to one decimal place, because they only want us to find an answer to one decimal place, there's only one value left, isn't there? Less than 5.7, because I've got to try a value of x that is smaller than 5.7 now, because 5.7 gave me an answer that was too big. So the only value of x to one decimal place I can try is 5.6, which I'm going to try now. So instead of 5.7, substitute it in, equals, let's bring up the calculator again. Okay, change that to 6. Change that to 6, press equals, 102.816. 102.816. Let's have a, right, so there we are, back on the whiteboard. There's the answer, 102.816. That, compared to 107, is smaller, so our value of x is too small. Right, so we don't actually have the answer yet, but we're almost there. Okay, now to one decimal place we've got nothing left to try, have we? Because if 5.6 gave me an answer that was too small and 5.7 gave me an answer that was too big, if I want to try another value of x in between those, then I've got to go to two decimal places, but they only want me to solve it to one decimal place. So that tells me the best answer is one of these two to one decimal place. It's either 5.6 or it's 5.7. Now how do I decide which one? Well, this is where you do have to go in between. Okay, and then we're going to do a little number line over here in a second to illustrate how we pick the best answer. Do not pick the best answer, do not pick the value of x that gives you the closest answer to 107. That is not always the correct answer. Okay, and you have to do this last step to get the fourth mark. If you don't do halfway between 5.6 and 5.7, you won't get the full 4 marks, even if you pick the right one. So here we go. Halfway between 5.6 and 5.7 is 5.65, of course. All right, so then we need to substitute that in. So type that in as quickly as I can. Right, let's get back onto the calculator. So we can just put a 5 on the end of our 6 there inside the brackets, nice and easy. Press equals, and we get 106.912125. 106.912125. 106.912125. You don't really need all those decimal places, to be honest, but for the examiner or anybody looking at this, I'm being as accurate as I can. I'm writing down the full solution, but 3 decimal places is enough, because all you've got to be able to do is compare it with this value up here. Well, as you can see, it's very close now to 107, but it's still smaller. 106.912125 is less than 107, so we still say this value of 5.65 is too small. Okay, this is what we do now. So we take our ruler and we're going to draw a line down here. Okay, like so. and on this end is 5.6, on this end is 5.7, and in the middle is 5.65. Now, underneath these three values of x, we write down what happened. So 5.6 was obviously too small, we can just write TS. 5.7 was too big, and then we looked at the value between those two halfway to see whether that was too big or too small, and that came out as too small. Now what that tells me is that if I carried on forever, because if you think about it, the problem with trial and improvement is, where do you stop? Do you go to 2 decimal places, 3 decimal places, 4, 5, 6? You could go on forever, couldn't you? To get closer and closer to 107. We're nearly there with 2 decimal places, but it's not quite 107 yet. And that's why they ask you in the exam just to give an answer to 1 decimal place. Otherwise you could be there forever. Okay, so if 5.65 was too small and 5.7 was too big, then if we did carry on forever, I would have to go between these two and pick values in here. So our answer, if I carried on trying to get a more accurate value of x, would be in this side somewhere. So I'm just shading that half of this little number line. So our answer would be in there if we carried on forever, but we can't carry on forever, we got other things to do. So the best answer to 1 decimal place is 5.7. okay, if 5.65 had come out as too big, then if we tried more values of x, we would have been looking in this half of the number line, in between 5.6 and 5.65, in between too small and too big, and we would have gone into that area if we carried on forever, and 5.6 would have been the best answer. So basically you shade in between too small and too big, because obviously the answer has to be between those two. So the best answer to 1 decimal place is 5.7, and always write your solution at the end like so. X is 5.7 to 1 dp, 1 decimal place. And there we have it. Okay, so a quick recap. So solving equations using trial and improvement, we use this method when they're not linear or quadratic equations, because we have methods for those. There are a couple of other methods for quadratic equations when you cannot factorize them, but that's for another video. So when we can't use those two methods and they're not nice linear, nice quadratic equations that can be factorized, we use trial and improvement. And as you can look at this equation, it was a cubic because we got a cube term. They told us it lied between 5 and 6. I showed you why they told us that, because the value of x gave us an answer that was too small. 60 was smaller than 107, and the value of 6 gave us an answer that was too big. You wouldn't normally do these two steps in the exam because they tell you this information. So what's the point in showing it? You don't have to. You would have started straight away with 5.5. So whatever two values they give you, you start in the middle and you work your way from there. So it's all about substitution and using a calculator. So we substitute 5.5 into the equation using the calculator, and we get an answer, and we compare it with the value in the equation, whatever it is equal to, wherever the equation where the body of x's are equal to. And that was too small, so we tried a bigger value. I jumped to 5.7. You may have jumped to 5.6 and got it quicker. There's a little bit of luck on how quick you solve these, but you can use a bit of common sense as well. So I thought 94 was a bit less, quite a bit less than 107, so I jumped to 5.7. When I substituted it in, it was too big, so I went smaller again than 5.7, which was 5.6, sticking to 1 decimal place because that's what they want me to solve it to, and it came out as too small. So then I knew I had my answer, because these two are consecutive. Remember, they follow each other. If we are counting in 1 decimal places, 5.5, 5.6, 5.7. So 5.6 is next to 5.7. It's consecutive. When you get to that position and there's nothing left to try to 1 decimal place, Okay, there's nothing between 5.6 and 5.7 to 1 decimal place. We have to go to more than 1 decimal place if you want to go between those. Then you know you have your answer. So it's either 5.7 or 5.6. To decide which is the best one, you've got to go halfway, 5.65. You substitute that in, check your answer, write down your judgment, too small or too big, and then we do this little number line to illustrate which one we're going to choose. So you write your three values, 5.6, 5.65, 5.7, too small, too big. The answer obviously lies between too small and too big. If I carried on forever, I haven't got time to carry on forever, so the best answer to 1 decimal place is 5.7. And don't forget to write it down. Okay, there we are. Hope that helps. Thank you very much.